Welcome back to Statistics and Data Analysis. Today we want to move to a new topic, estimation. We will apply the knowledge about probabilities we have learned, and we will teach you how to, facing an unknown population, how may we do some estimations about it. So I will first introduce the basic idea to you, and then we will talk about how to estimate population mean. How to estimate population mean in today's lecture. Later, in the Monday's lecture, I will give you other examples about how to estimate other population parameters. But in the video, I will only talk about population mean. If you can establish the correct concept, then estimating other things basically just follow the same process, same kinds of process. We will split our discussion to two scenarios. Either we know the population variance or not. Okay, so let's start. Let's motivate this study with the following example. Suppose I run a retail chain and I have 3,000 stores around the world or around my country, around Taiwan or around a specific region. Okay, in total I have 3,000 stores. Next Monday I'm going to have a special discount or any kinds of promotion program on these 3,000 stores. And as a manager, I probably want to know the effect of that special event. I want to know on that next Monday, what's the average number of daily consumers entering the store. So for the next Monday, there is a specific date, and I'm going to ask how many consumers entering the first store, how many consumers entering the second store, and so on and so on. So I'm going to have 3,000 numbers, and I want to know what's the average. Okay, so that's the problem. I plan to do a survey on the next Monday. That's something that I plan to do. And on that day, I know consumers will enter. I'm going to collect 3,000 numbers. The thing that I want to estimate is the average effect of that promotion. I want to know what's the average number of consumers entering the store. Okay, entering all the stores. So mu is for population mean, right? Today, I of course cannot predict what's going to happen on that next Monday. What's interesting is that even at the end of the next Monday, after all the stores are closed and all those XIs are finalized, I still do not know mu, right? Even after those numbers have realized, I do not know mu because I did not do a survey on all those stores, right? The only way for me to know mu is to know all the XIs, but sometimes I just cannot or have no way to know all those numbers. Then I need to somehow estimate that number. I need to estimate this population parameter, which is population mean. So if I have enough money or enough employees, I will really try to for each store, I'm going to hire one guy standing at the door, and whenever one guy comes in, I'm going to add the counter to +1 and so on and so on. Okay, but unfortunately, my budget is limited, and I can only hire 7 temporary workers to count the number of consumers in that day. Okay, so I will randomly draw 7 stores and calculate a so-called sample mean. I'm going to only look at 7 stores, having one worker at each store to count how many number really go into my store on that particular day. Okay, so that's something I plan to do. Suppose at the end of that day, my survey got these numbers. Okay, 1026, 932, and so on and so on. It seems to me that these numbers are somewhat centered at 1000, and also I can see the sample mean is 960. Okay, it's just sum these 7 numbers up and divide it by 7. So based on my knowledge about sample mean, I know it somewhat has a close relationship with population mean. And intuitively, everybody will say that if my sample mean is here, then the population mean should somewhat be around 960. Okay, that's some intuition we may have. Or we may say that, yeah, mu must be around 960. So let me guess. I guess mu is within 950 and 980. Okay? When we make this kind of statement, we somehow hope that we are confident about it, right? We hope that, let me say it roughly speaking, we hope that the probability for this to really be true is high. Okay, that's something we hope. Actually, mu is there. Okay, on the end of that store, mu is there because the 3000 numbers are there. It's just that we don't know it. It's just that we don't know it. The only thing we know is these 7 numbers from our sample. And from our sample, we made this kind of conjectures or this kind of estimations. We know intuitively it's true. It should somewhat capture the true result, but we just don't know how accurate we are or how confident we may be. Okay, so we want to ask, in general, when is it okay to conclude that the population mean is really within a distance 10 from the sample mean? Okay, we want to know whether it is good to make this kind of estimation. So this actually is just one of the most important statistical tasks, okay, which is called estimation. In these kinds of tasks, there will be one or several unknown population parameters, just like the population mean we discussed in the previous slides. For that particular parameter, we will do some estimation through statistics. We will sample from the population and then calculate some statistics as our estimates to the population parameter. Okay, this of course only happens to the case that we cannot do a census. If we are only allowed to do a sampling, then statistics will be used to estimate parameters. Okay, so the most important thing is that we want to go beyond intuition and conjectures. When we see 960, we always guess, we always intuitively guess that the population mean should be somewhat around 960. But we want more than that. We want that after we make any kinds of estimation, we can also know how accurate that estimation is. Okay, that's the whole point of learning sampling distributions. That's the whole point for learning probabilities. In particular, when we know something about that particular statistic, we know something about our sample, we can really make that accuracy judgment. Okay, For example, we know sample mean follows a normal distribution whose mean is just the population mean and whose standard deviation can be calculated according to this formula. Right? We know there are some assumptions about it. When those assumptions are satisfied, we know the population sample mean is just this. And given our knowledge about sample mean distribution, may we say anything? No, that's today's topic. So in statistics, we will create confidence intervals to estimate parameters. We will claim that population mean, for example, population mean is within that interval. Okay, within 950 to 970 or some other intervals. And then we will estimate or we will verify how accurate our estimation is. Okay, so today we will talk about population mean. Thank you.